Okay, so question 9 from today, a little bit of a challenge question I set you. I thought I'd just make a video showing you how I did it. So I have a few things sketched down here. So in the question told us there was two tangents, x plus 1 equals 0 and x minus 3 equals 0. And it also told us that the centre lies on the line y equals 3. Now, I've done two things here before doing anything else in the question. I drew out a rough sketch. So the two green lines are my tangents. So x plus 1 equals 0. So that's x equals minus 1, x minus 3 equals 0, x equals 3. So I've got one tangent going up through x is 3, the other tangent going up through x is minus 1. And I know the centre lies on y equals 3. So there's y equals 3. So I know the circle lies in between these two lines, and that this red line is going through the exact centre of it. Okay, so we'll come back to that later to see if it's in any way helpful to us. Another thing I've wrote down here is if the centre lies on y equals 3, then the y value of the coordinate has to be 3. Okay, so if our centre is hk, well then I already know that k is 3. So really I'm just looking for h. Now, if you think about it, from our tangent to your point, just like question 8 and 10, we can use our distance from a point to a line formula. Okay, so we'll use it here too to help us find h. So from point to line, but now remember your line is in the form of ABC, okay? Or sorry, yeah, ABC and XY. So you can see here are two tangents. We've got x and c. We've got our constant, we've got our x term. We haven't got b, so we'll just have to put in 0 for that. Okay, so writing out the formula, I'm going to say, so we've got a x1 plus b y1 plus c absolute value all over the square root of a squared plus b squared. Okay, so I'm going to use this formula to find the distance from the centre to the tangent x plus 1. Okay, so my a value is coefficient of x, which is just 1. There's my a. My c is my constant, which is 1. I don't have b. So it's going to have to be 0. Then my x and y is h and 3. So fill this out now, see how we get on. So we've got a coefficient of x is 1 plus b is 0. So, sorry, forgot my x. My x is h. Squeeze that in here. So multiplied by h. Then b, which is 0, multiplied by y, which is 3, plus c, which is 1. All over 1 squared plus 0 squared. Okay, so h times 1 is just h. 3 times 0 is 0, so that's gone. Plus 1. All over 1 squared, 1 plus 0 squared, 0. So we just got the square root of 1, which is just 1. Now, this is the distance from this tangent to the centre. However, the distance from the centre to this tangent and the distance from the centre to this tangent should be the exact same, because you're going from centre to outer circle. So you're going the radius length basically. Because in a normal circumstance, if we knew what this was, this would give us what the radius is. So I can actually let that equal again now. So now I'm going to use the other tangent. So that's a squared plus b squared. Okay, so this time I'm using the second tangent we were given. So again, I've no b, so So my A is coefficient of x, which is 1. My C is the constant, which is -3. So B is going to have to be 0. Okay, so A, again, we've got 1 times x, which is h, plus B, which is 0 times y, which is 3, plus C, which is -3, all over the square root of A, so 1 squared plus 0 squared. So these should be equal. So we've got h, 0 times 3 is gone, so that's just 0 minus 3. All over 1 squared is 1, 0 is gone, square root of 1 is 1. So what we're left with is h plus 1 equals h minus 3. So sorry, the absolute value of h plus 1 equals the absolute value of h minus 3. Okay, so to get rid of the absolute value, you square both sides. So h plus 1 to be squared equals h minus 3 to be squared. Okay, so then squaring these out. So again, recommend going out the rough work, doing them out the long way. Okay, I wouldn't try to do them in your head. So h plus 1 to be squared, that's going to give me h. So h times h is h squared plus h, so you've got 2h, 1 times 1 is 1. And this should be equal to h minus 3 squared. So again, I'm going to have h times h is h squared minus 6h plus 9. Okay, so please do that out properly. Don't do it in your head, just like I did. Now it's a matter of bringing everything to one side of the equals, dividing down, isolating h. Okay, so if we bring everything over, so all h is to one side, constants to the other, so I'm going to end up with h squared, bring this h squared over, is minus, then this 2h is over here, minus 6 brought over is plus 6, equals 9, bring that one over, minus 1. So the h squareds cancel out, cancel, then 6 plus 2, I've got 8h equals 9 take away 1 is 8. Okay, so no mystery here now of what h is. Divide down by 8, h equals 1. Okay, so now we know that h is 1, we can go back up here. So that means our centre equals 1, 3. Okay, so we know our centre is 1, 3. We're trying to create the equation of the line, so we also need the radius. Okay, so there are a few ways now you can get the radius. You can go back now and put your value of h into here and see what it gives you. Okay, so if we put h, so 1, so if we say 1 times 1 is 1, 1 plus 1 is 2, so this would be 2 over 1, so radius is 2. Or from our quick sketch here, you can see, so from tangent to tangent would be the diameter, so 1, 2, 3, 4, half the diameter is 2, so either way radius is 2. So then the equation of the line, so you're going to have x minus 1 squared plus y, sorry, forgot there, minus 3 from our centre squared equals, or for radius we found out to be 2 squared. Okay, so you could write that out again, make that 4. Okay, so that is how I did question 9 using our tangents. Okay, so remember, if you've got two tangents lined up side by side here, you know that's going to be your diameter. So you could use that way to get your radius, or just plug it back in here, the more traditional route. So compare this to what you did and see how you get on.